Hey there. Ever tried following a recipe where half the instructions were wrong? Imagine baking a cake with swapped measurements. What's the point of the oven if the ingredients are off? That's basically what AI models face when trained on noisy data. Data full of mistakes, contradictions, or even lies. But here's the twist. Researchers are finding smarter ways to help AI ignore the chaos and learn the right lessons. Today, we're diving into a breakthrough called Hölder-DPO, a method that's like giving AI a pair of noise-canceling headphones for training. Let's break it down. So why is noisy data such a big deal? Think of it like a classroom where some students are giving wrong answers. If the teacher just repeats those answers, the whole class ends up confused. Similarly, AI models trained on flawed data can start producing weird or unsafe results. For example, a chatbot might learn to ignore helpful advice if it's flooded with conflicting feedback. Now, here's the problem. Traditional methods for cleaning this data are like trying to find a needle in a haystack. They either miss the errors or require tons of human effort to fix. But Hölder-DPO, it's like having a super smart assistant that automatically spots the bad data while the model is learning. How does it work? Let's simplify. Hölder-DPO uses a mathematical trick called the redescending property, which basically means it ignores data points that don't fit the pattern. Imagine you're teaching a robot to recognize cats. If a photo of a dog is mistakenly labeled as a cat, Hölder-DPO flags it as an outlier and says, "Hey, this doesn't belong here." Here's the magic. Instead of relying on complex calculations, it looks at how likely each data point is to be correct. If a label seems out of place, like a student's answer that doesn't match the rest of the class, it gets filtered out. This means models can clean datasets on their own, without needing humans to check every single entry. Let's get a little technical, but don't worry, we'll keep it simple. Hölder-DPO uses two tools, the PS score and the DP divergence. Think of them as detective tools. The PS score helps the model spot weird patterns, while the DP divergence acts like a trust meter, telling the model which data points are reliable. Together, they help the AI separate the sugar from the sand. But here's a hiccup. Early versions of this method had a math problem. They tried to estimate how much good data there is using a formula that could accidentally say, hey, 120% of this cake is sugar. That doesn't make sense. So researchers fixed it by adding a clever trick. They normalized the calculations using the model's confidence. Like double-checking your recipe by asking, how sure am I this ingredient is real? This ensures the final answer stays between 0 and 1, like a proper percentage. When researchers tested Hölder-DPO, it blew away older methods. In one experiment, they added 40% fake labels to a dataset and let the model learn. While other methods struggled, Hölder-DPO not only cleaned the data but also estimated how much noise was there, all without extra help. The result? Models that were safer, more accurate, and better at following human preferences. Think of it like training an AI to recognize cats in photos. If 10% of the images are actually dogs, the model needs to know which 90% are real cats. Hölder-DPO doesn't just find the cats, it also tells you exactly how much noise was in the dataset. This is a game changer for AI safety, especially in critical areas like medical diagnostics or autonomous systems. This isn't just about fixing errors, it's about building trust. By teaching AI to handle real-world messiness, we're creating systems that are more reliable and aligned with our values. The next time you chat with an AI, remember, it's not just memorizing answers. It's learning to ignore the noise and focus on what matters. Thanks for watching. If you want to see how this tech could shape the future of AI, hit subscribe. And drop a comment. What's one thing you'd want an AI to learn from your feedback? Until next time, stay curious.